Hey, this is chapter 7. This is the third part of chapter 7. You'll notice that there's a section before these 2 pages that I'm starting on. I have crossed them out on this paper because these are normally things that would take a whole lecture to talk about, but we are skipping the material and we'll just cover it more in detail in Gen Chem 2. So you can put a big X right here and right here. So we're starting right here. This is kind of the big deal of chemistry, this chapter. This is all about the reactions, and I already mentioned that. But this within the chapter is the biggest part of what chemistry is about. So I've got all these videos, of course, like before. Again, it's a very popular chemistry topic. You'll see DeWitt right there. He has practice problems. A lot of people like those practice problems, just to watch people work more problems. So we'll work a lot of problems too through the notes. I've changed this page and the next page just a little bit, but enough. Like this section that's right here, I actually had it on this page right here. So you may want to change your notes. You don't have to. You'll be able to get by without it, but this version is more clear. I changed it within probably 3 days of my having uploaded the notes, so it depends on how many you printed. In this section, we're going to be looking at something specific. But before we do, I have to remind you guys of something you already know. Way back in chapter 2, you actually learned this, though you might not have realized that you had learned this. So in chapter 2, we talked about how if you know how many moles of something that you have, we talked about how you can use Avogadro's number and get to the particles, the number of atoms, the number of pieces that something has. And then we also talked about how you could use the molar mass, and that's that number on the periodic chart, the grams per mole number. That's the grams per mole number. And you can use it to get to the mass of something. So that was chapter 2 in both of those cases. Chapter 2, chapter 2. And then in chapter 6, we mentioned this was the last test, and that if you know the molarity of something and you know the number of moles, you can figure out what the volume of something is. And all these are back and forth arrows, so if you know the volume and the molarity, you can figure out the moles. So none of this is new. And this right-hand side, it's actually a mirror, so it's saying the same thing. You'll notice again, you start with that main thing, the mole. So we've got the mole right here. And again, you can use Avogadro's number, that's at 6.022 times 10 to the 23rd to get to a number of particles. You can use a molar mass from the periodic chart to get to the mass of something in grams. And you can use molarity to get to the volume of a solution. And I haven't overly focused on this, but we did do a few problems in chapter 2 where you use density to get from mass to volume. Density is that. And so if you have a mass, you could see where you could use density to get 2 milliliters. We're not going to overly focus on the density part at this point. In fact, there aren't any problems even involving density that I'm having you guys work. So you've done this before. Here's what we're changing in this chapter. We are introducing the idea of if you know the moles of something, you can get to the moles of something else. And the way you do that is with those balancing coefficients, those numbers in the front. We call it a mole-to-mole ratio. So we have a mole-to-mole ratio, and it's how you can move from one thing to another. So we have this coefficient in front. If I know the number of moles of hydrogen, is that I can relate that to the number of moles of oxygen to figure out how many moles of oxygen that I need to have the reaction go to completion. Also, I can figure out how much product I'm going to make. This is very useful information. So as a review, from this reaction, 2 moles of hydrogen gas reacts with 1 mole of oxygen gas to produce 2 moles of water. Now, if we look at this carefully, again, this is re-emphasizing these ratios. So I can say that this is 2 to 1 or 1 to 2. I can say that I have 2 moles of water, 2 moles of hydrogen, or I can say I have 2 moles of hydrogen in 2 moles of water. Note that this is the same thing as saying 1 to 1. Like I could say that those two cancel and it's 1-to-1. It's a little less work to put in your calculator that way. So I kind of recommend canceling it, but if you're uncomfortable and you just want all the numbers in your calculator, that's totally fine also. All right, now we're going to go from moles of oxygen to moles of water. So my water's the 2. Notice it's 2 right here. My oxygen is right here. So my oxygen is right there. And I can go from 1 to 2 or 2 to 1 on my moles of oxygen.